All right. Hello, LinkedIn. I am here live with Tyler Whitehouse, the president and CEO of Gigantum. Hi, Tyler.
Hello, Kate.
How's it going?
It's going well. It's a little rainy out there today, colder than I wanted it to be, but other than that, it's been pretty good.
All right. Well, why don't we start with tell us a little bit about yourself, and then we'll get into the topic.
Okay, let's see. My name is Tyler, as we said. I have a background in math. I did a PhD at the University of Minnesota, graduating in 2009. Paper and pencil, sort of approximation theory type stuff that most people didn't care much about. And then later did a postdoc at Vanderbilt for 3 years in much of the same things. And then left academia in 2012 to work as a consultant for a variety of government agencies in DC. And I worked on sort of mathematics, machine learning, and statistics programs, cutting myself off. And so I did that for probably about 5 or 6 years, did a lot of data science in that as part of the consulting work. And then about 2.5 years ago, some guys out of Johns Hopkins that I had met in the course of the consulting work, especially at DARPA, they were going to start a company, and so they asked me to join and come on and run a variety of the strategy, business, operation stuff, and it seemed like a good deal. They're all smart guys, so
Was
it was
that
a no-brainer.
company called Gigantum by any means?
That is the name of the company.
right.
Yeah, that's the name of the company.
All right. Well, welcome to the Dedicated show here, and the topic of this conversation is going to be DIY deep learning. So do-it-yourself deep learning. And before we get into that, maybe you could tell us a little bit about what is deep learning.
So for me, as somebody who's not a sort of an experienced machine learning practitioner, the way that I typically think of deep learning is in the context of machine learning in general. So, I'm sure a lot of the people listening, maybe some of them weren't doing, machine learning 10, 15 years ago when deep learning was sort of not really a thing yet. Deep learning, as far as I see it, is really related to sort of function spaces and functional approximation and your ability to learn a function. And what makes deep learning special is that the function space that you're drawing from is extremely rich, extremely robust, and sort of it generalizes out of sample very well. And that's in distinction to things like polynomials or other kinds of functions that you can fit data with. But polynomials, while you can fit a certain set of data points, basically when you move off of those, you can have arbitrarily bad errors. So deep learning, I really think of it in terms of function spaces. So
All right.
yeah.
And for those joining us, just to remind you, we're talking about DIY deep learning with Tyler Whitehouse. I see we have a couple people that joined. I see Andreas, Dinesh, and Harsh, Fernando. Thank you guys for joining us. If you have questions for Tyler on deep learning or Gigantum, please go ahead and put that in the comments and we'll be happy to address them. So I think the next thing we can move to is, why do you think that there's a need for people to, quote unquote, do it themselves?
Yeah, I mean, so, for companies that can afford staff and software, there's, the only need to sort of do it yourself is basically one of cost savings. But for sort of ordinary people, it's very different. And, given the last 15 years of the explosion in open source software and how much more user-friendly it is, and also more recently sort of the availability of like easy cloud compute, do-it-yourself is now a bit of an expectation rather than something that people feel lucky to get. So why is it good? I mean,
why can't people just, hire others or buy software?
Well,
Is it just the cost?
I mean, it's usually the cost.
Yeah.
I mean, an average individual, like if I have some idea, some sort of a product, and I know that it's going to involve some machine learning, until I get a bunch of money from investors or some other sort of revenue, I kind of have to do it on my own. So
Yeah.
the world in which I'd have to rely on expensive software or another person to do it is a world in which it doesn't happen.
Yeah.
So there's that aspect. There's also sort of the democratic aspect of it. Like the more, quote unquote, ordinary citizen data scientists are connected to more advanced techniques and computational power, the more power they have as people.
Yeah.
And I'm all about that kind of distribution of power because, as we know, consolidating too much power in the hands of any one individual or company, etc., it's a problem.
Not good? No?
I
Why?
don't think- well, because then what it means is that you don't have a consensus about the decisions and that sort of thing. Yeah.
All right, I think before we go to the next question, why don't you tell everyone a little bit more about Gigantum? What
Sure.
does that company do?
So Gigantum started about 2.5 years ago, and it was largely a response to the reproducibility crisis in scientific research.
There's a reproducibility crisis?
Yeah, you haven't heard
Say
of
it
it?
isn't so. No.
Yeah.
What's the crisis?
So basically, the reproducibility crisis sort of first started in the social sciences and psychology, and then it moved into the medical sciences, and then it became a bit more of a topic in the computational world. So the first thing is, somebody gathers data.
Yeah.
They do some sort of an experiment, or it's observational data, and then they do some analysis, and they have the results that are based on it, and then they either don't give the data to somebody, or they do give the data to somebody, and when they do give the data, the other person tries to reproduce their experiment, and it's broken. Doesn't work.
Something
Your code is
doesn't work,
broken, this data is wrong, I'm getting wrong results, etc. And so this idea of like reproducing or replicating somebody else's work is something that goes all the way back, is sort of fundamental to the scientific method. Like one of the basic principles is you must be able to reproduce or replicate, because you have to have consensus and independent verification. So this has been a crisis at the funding level, at the journal level, and also sort of at the researcher level for a while. And so we got involved because a lot of the problems are computationally related. And so it's not just bad science or inattentive science that causes reproducibility problems. It's also the fact that the world that scientists live in now is largely digital, which means computation, which means software, and all of that is very difficult to reproduce for other people. So the basic idea for the software is, how do we solve the transaction problem for data, code, and environment within the context of computational reproducibility? And how do we do that using the tools that are coming out? 5-6 years ago, Docker was pretty new to the world. Academics very quickly fastened on Docker as a way to solve certain reproducibility aspects, but it was mostly a manual process. Like you have a researcher, they make some sort of a Docker file, they share it, and then they play these games. But we realized you could make a product based on it that would sort of automate all this kind of stuff. And so that was sort of the basic idea for the company. The product itself really is a work environment, and it runs in a container. So if you can install Docker on a machine, be it your laptop, a workstation, or in an EC2 instance, DigitalOcean, what have you, you can install the software. It's browser-based, you can interact with it, and then it acts sort of as like a little system admin, sort of invisible, like Keebler Elf, does all this kind of stuff. While if you want, you work in Jupyter, you work in RStudio, and it just provides all these kinds of benefits. And one of the big benefits is if you're working on your laptop and you're using Gigantum, I'm working on my laptop, if we want to work together, we don't have to use GitHub, Git commit, and all these things.
So it's like GitHub.
But just like
better.
But well, I would never, that can get you in a lot of trouble. I would never say that. It's different.
You didn't, I did.
It's solving a different problem, but it lets people who might not have the facility with versioning software containers be able to essentially play tennis with a piece of work. Like
So
I hit it over the fence, you hit it over the
code
fence.
at the same time.
Same time. And like it's all sort of
And
nicely
track
managed.
all the updates.
Everything,
Right.
Yeah. So that's one of the things.
Okay.
Yeah.
We had a question come in from Saim. So, what are your thoughts on the young generation, millennials, Gen X, interested in diving into like machine learning in this space?
I would say that given the level of tooling and how much easier it is to get access to computational power and the actual sort of high-level APIs like PyTorch and that sort of stuff that lets you do it, the most important thing is to learn the math and learn the statistics, because while it's easy to do deep learning, it's even easier to do bad deep learning. And like for every magical story you hear about somebody solving a key problem, there's probably a factor of 1,000 more that like did something terribly bad and their model sucks and like they don't know it. So like learning the statistics and the math and that sort of stuff is probably more important than learning how to do the actual programming right now, because that's just getting easier and easier and easier.
Yeah, that's actually, I wanted to touch on that when you were talking about kind of data democratization and allowing people to have the power to do things, because when you allow more people to do things, it can also go really wrong, right?
It can, but the interesting thing, it can, but that's where reproducibility comes in, because the idea is, imagine, you're a company and you hire some people and they come in and you sort of, they make this model, they do all this stuff, and they say to you, look, this works, here's the proof that it works, we have this training, we have this validation. If you don't have the ability to go in and crack it open and reproduce it and look at it and manipulate it, you're sort of at the mercy of trusting them. But if you have the ability to take it, play with it, without any sort of extra effort, I don't have to set up environments, I don't have to do this, something manages it for you, then you can actually probe it.
Saim, you're welcome. He's thanking you for answering this question. All right, another question came in from Alex Vayner. Hey, Alex, good to see you on here. So, Tyler, reproducibility challenges are mostly prevalent in social sciences, but don't seem to be an issue in hard sciences. Can you comment? It seems like the challenge is the computational space in general, not just version control.
So, I would say that I don't know how true that is. I think it depends. Like computational biology has problems. Computational neuroscience, which is what some of the other founders were in, like they have been having their own sort of mini crisis for a while.
Yeah.
Physics, astronomy, I don't know. High energy physics, that sort of stuff, I don't know. But I do know that in various parts of biology, it's a thing. So there's that. What was the rest of the question?
Oh, sorry, there's a lot more that came
So,
after.
for example, there's a famous paper in neuroscience where somebody did a whole experiment on a dead fish. There was some like computational models, a lot of signal processing.
What kind of fish was it?
I think it was a salmon.
I love salmon.
So there's a paper that's sort of a joke paper, but the goal was to basically expose the lack of reproducibility in neuroscience, sort of the analysis of a dead fish. So you can check that out, and I can post things on our page to show people that it is a bit more of an issue.
Yeah,
and then the computational space in general, you're right, like, the reproducibility crisis in AI, all kinds of articles out there about that. And, that is also part of what we're attacking. And with respect to sort of the more computational hard sciences, like neuroscience and comp biology, those computational issues play a role in the reproducibility crisis outside of the kinds of methodology problems that you've correctly identified in social sciences. So I don't know if that answered the question.
Yeah, and for those that are tuned in and want to follow more and take, these types of topics, you should follow Gigantum. They have a company page that they post this type of information. So let's move on to the next question. Fernando, in your opinion, what is the ethical scope about deep learning in companies? And in this line, what do you think about the use of this for creating fake news?
Terrifying.
Yeah.
I mean, companies are like people, and obviously there's a pretty broad distribution.
Companies are people. No?
Well, they right, which is a little weird.
Yeah.
But like there is a pretty broad distribution of ethical responsibility there. So the potential for deep learning, machine learning, and computational power for social evil is very high. And like the whole deep fakes thing, I don't know too much about it other than some of the ways that they generate it using GANs and stuff like that.
Yeah.
But I think the one thing that we have in our favor is that, again, going towards reproducibility, people are beginning to adopt sort of a more forensic mentality on machine learning methods, on the outputs. And as far as I know, when you look at sort of these deep fake things, one of the problems is the statistics are wrong. They don't sort of fit natural images. And I may be wrong on that now. Maybe people have found ways to fit that more properly, but that's not something that your average consumer is going to be able to identify with the naked eye.
Right.
And given the lack of faith in any sort of external independent verification now, it could be basically over. Like,
yeah,
I
that
don't
is
know.
scary.
Maybe this is not real now. Like
It isn't. We're not actually here.
Right. So
All right, let's go back to one of our questions here. So what are some obstacles that people or companies face when they're trying to do deep learning by themselves?
So, I mean, as far as I can tell, there's three basic obstacles. The first is hardware, right?
Hardware, yep.
The second is software, and then the third is money. And depending on where you are, those things are all sort of involved, right? So, I guess it was about in 2007, CUDA came out, which changed the way that people could interact with GPUs. So people may not know, but prior to that, GPUs were 100% graphical processing units. And if you wanted to program some sort of a computational routine into that, you had to use you had to translate your computations into a bizarre language that had to do with manipulating geometric objects. And so that's why they created this sort of layer on it, this programming framework. So in the world of GPUs back then, because there weren't these sort of available cloud ones, you had to create a machine or buy a machine. And making a machine, not necessarily easy. You can do it. There's all kinds of articles on Medium like, oh, it's easy to create your own rig. Maybe. So that's one thing. But now that the cloud computing has sort of removed that, in some sense, hardware isn't an issue until you get burned by cloud charges. So the next thing, of course, is the software stack, which because you have to have these various layers between the higher level programming languages and the low level machinery. There is a huge stack of software that you have to install in terms of drivers and then NVIDIA drivers.
So just
and then
complexity of that.
The complexity of that. And at that lower level, that in some sense is fairly straightforward to install. But once you get above that, you have all these other libraries that have a lot more variety in them, different versions, and that can sort of put you into sort of a version of dependency hell. And that, of course, has gotten somewhat easier.
Yeah.
And as some of the Pythonic frameworks like PyTorch, TensorFlow, this sort of stuff that's on top, that has made it a lot easier. But this middle part of the stack is still hard for people to do. And then the third thing, of course, is cost. So buying a Jeep, like buying a local machine for $5,000-$6,000, which is a large upfront cost. But when you compare that to the cost for running things in the cloud, especially if you do a lot of computation, there's some sort of cost savings there as long as you have the skill to do it. And then the other thing in terms of cost, there's all these sort of managed data science platforms or deep learning as a service where you have somebody that basically takes care of the hardware, they take care of that whole software stack, and all you have to do is be able to sort of click buttons, pay some money, write the appropriate code, and do that kind of stuff. And usually there's a premium, there's a markup on the compute, and there's a premium, et cetera. So those are the three barriers.
So in terms of money, I know it's probably a difficult question, but how much money?
I mean, I know somebody,
but...
there's a guy that I met a couple months ago that started a company called Sight AI.
Okay.
And what they do is they use deep learning to analyze, they do like sort of quality analysis of scientific citation, right?
Okay.
And he said he got, a certain amount of credits from Amazon, and they were doing it all on Amazon. And he's like, we just blew through that. And then they had another set from another vendor, and he's like, we blew through that too. So he said, finally, we had to just knuckle down, buy our own machine, and learn how to manage it.
Wow,
and these grants are on the order of $100,000.
Wow.
And he did this in less than a year. So, right?
Yeah.
And you can spend $500 a week training a model just with sort of a cheap GPU instance.
Yeah.
Now, to a company, that's not a lot of money. To certain individuals, it is. So, if you want to do that a lot, maybe instead of, training for like 5 or 6 months and stopping, just buy a rig and do it yourself.
Yeah. Okay. And so how does Gigantum solve some of the problems that you just discussed?
So Gigantum, because it acts as this sort of middleware, this ergonomic layer, it solves basically the part that sits above the drivers. So like if you were going to do deep learning and you're like, okay.
I'm going to do that tonight actually.
Are you?
Yeah, I was going to go home
in the class?
do some deep learning.
Oh, well you can actually follow that article and just like super easy.
This article?
Yeah.
This one?
Yeah.
Yeah. There's an article. We'll talk about it later.
Yeah. So basically once you get the instance stood up and then you get 2 drivers installed, which is a graphics driver and then the NVIDIA driver.
Yep.
After that, all you do basically is just install Gigantum. And then what happens is it sort of puts
and is that free? Is all this free?
So Gigantum is MIT licensed. Yeah, so it's open source free. The MIT license is just a super permissive open source license. It's much preferable. It's more preferable than like the copyleft things, all of the Richard Stallman sort of aggressive licenses and that sort of thing. And it means that anybody can use it, can commercialize it, do whatever they want with it. And it's sort of, we did it for a variety of reasons. We did it because one of the contracts we had forced us to do it. But we also did it because we realized the best thing about the software is to get people to use it, to get people to alter it without having any fear that it's going to infect the rest of their stack and that sort of stuff. So once you put on Gigantum, basically it sits in between you and all the drivers, and then it just manages literally everything else for you. So that's the major thing that it does. Another aspect that I didn't really say is that, once you set up some sort of a system where you're going to do your deep learning, being able to use different software environments in that. Maybe you're using CUDA 9, maybe you're using CUDA 8, you're using CUDA 10. Typically that is sort of a pain to navigate, whereas in Gigantum, once you install the basic software, every time you go to make a new workflow, you get to pick whatever you want, and it's completely decoupled from what it's sitting on top of. So that's a major thing.
Yeah. Okay, thank you.
Yeah.
We have a couple of comments coming in here. So let me scroll up. All right, Andreas says, hi Andreas. This is actually very true.
Yeah.
Hardware is a lot cheaper than to do learning 24/7 in the cloud.
Yeah. Agreed.
Yeah. All right, Eric. Applying deep learning to recommender systems is an interesting area. What is your knowledge about it, and what are new research trends?
So my knowledge at recommender systems stops at the Netflix challenge.
I was just going to say Netflix.
So I think that's 2009 maybe. So yes, that's
Okay,
that's
so
where
we're
my
gonna move
knowledge
on.
stops.
So-
I mean, again, as with any sort of classifier, like and feature learner,
Yeah.
it's better than everything else. So as long as you have enough data, it's probably going to perform better. I mean, the areas in which they've shown that deep learning is not good in compared to standard statistical methods
Yeah.
are for things like time series prediction, et cetera, where you can't generate enough data, and so you're best going off with sort of tried and true statistical methods. Recommender systems always been a little different, very ad hoc. Like if you look at a lot of the methods around the Netflix thing, some of them were fairly mathematical, like matrix completion and matrix decomposition, but a lot of the other ones were just like rando stuff that people did. So.
All right, another question from Andreas. So when do you use this tool, Gigantum? Is it during the proof of concept phase or something else?
I think that's a good, I haven't stated it that way, but I think it's a good way to think of it. It's not, it's for exploratory work.
Yep.
It's for exploratory work that you maybe want to do on different machines. It's for exploratory work that you want to do with different people. But it's not something that's going to help you move things to production yet.
Okay.
We're developing stuff that will help you do that and do things in batch. It's not something if you're going to be working in an HPC environment because it just runs on top of Docker. So like you're going to have like there's no scheduling or nothing like that. And in general, in any situation where you're going to sit down and you're going to do some work in a Jupyter notebook or Jupyter Lab or in RStudio, and you want to make sure that everything you do is basically just like videotaped,
Yeah.
then this lets you do that.
Okay.
Yeah.
Cool.
It's good for, so one other thing, it's good for product delivery too. So if, for example, like if you are just trying to create some sort of a routine, suppose you're an instructor.
Yeah.
And you want to create some sort of complicated environment that you know your students are never going to be able to do. This is one way to do it. So for example, CERN has this C++ data analysis library called Root.
Okay.
And then they have a Python wrapper for it, which is called PyRoot. And in general, usually C++ libraries with Python wrappers are a nightmare. Nightmare to install. There was a very good network analysis library called iGraph. The most popular one now is NetworkX. In my opinion, iGraph was way better.
Okay.
But because it was such a nightmare to install, very few people used it. So one of our founders, Randall, he's the head of the Department of Computer Science at Johns Hopkins. I said, hey, Randall, why don't you get this like root thing all set up? And so he said, okay. Randall, did his computer science thing. Boom, put root in it and published it. And now anybody in the world can use PyRoot, even a high school student that would have no ability to install it. So this kind of product delivery as well is what it's for.
Okay. Thank you.
Yeah.
All right. Eric asked for the link to the article.
Sure.
We'll talk about the article later, but I'll just
Sure.
go ahead and submit that. Madi, please scroll up for my question. All right. Sorry, I missed it. Let's see. Okay. How to explain deep learning outcomes where the business is looking for why or how the model came to this result?
Sure. So I remember, for a little background, if for anybody that is learning about the power of deep learning and wants to push back on the notion of like explainable AI or like explaining the model,
Yep.
all you have to do is go look at computer vision between the years of 2003 and 2009 or 2010. Maybe even 2012. And what you will see is a field that is full of explainable, but completely ad hoc and extremely complicated and not very performant methods, okay? And this was sort of in the whole feature engineering time where, people had these very complicated, what we often call Rube Goldberg devices, these long pipelines, extremely intelligent people. Extremely intelligent people, but just lacking the fundamental technology to do this. But all of it explainable. And then deep learning came along, 2011, began to sort of make serious strides in this, and then pretty soon, 30 years of research was flushed down the toilet. But whatever, that's science.
Yeah.
So I remember working at DARPA and watching all of these previous computer vision experts say, well, but it's not explainable. What we need is explainable artificial intelligence. And then people are like, oh, okay.
Explainable
that
to
makes
who, though?
Well,
Who has to understand it?
what does explainable mean as well, right? Like, does it mean a qualitative model that you can write out with rules? Does it mean you understand how it changes probability distributions? It wasn't clear what it meant.
Yeah.
But so there was this group of researchers that were, and this is a little bit of a conspiracy theory on my part, but it was this group of researchers that were being pushed out, and so they made all this noise about it, and then all of a sudden, whoa, it became a thing, and they're like, well, we can't trust deep learning because it's not explainable. Well, it is explainable. It's a function space.
You're smart enough to understand it?
Well, it's explainable in that it's a function space that's very rich, etc. The
Yeah.
problem, of course, is that you can't prove any theorems about it. There are some theorems that are proved about it, but in general, when people prove theorems about like functional approximation, what you want to know is sort of input error versus output error, which is
Yeah.
sort of a calculus type problem. And then the next thing is like, well, what does it do with the probability distribution, right? What are these errors? And you can't really do that with deep learning because they don't understand how it works well enough. The mathematical techniques have not really been invented. That's not to say there aren't any theorems or whatever.
Yeah.
So I would say that basically it should be phrased essentially like that. Like, there's a lot of empirical evidence for it. We don't have any proofs for it, but nor did we have any proofs for all the human understandable feature engineering we did before. We just had a bunch of people who could make a diagram and say, see, here's how it works.
Yeah.
But they couldn't actually give you any reason, any theoretical reason either. So for me, it's no different. It's just a label that's been applied, and you just have to kind of push back,
Right.
in my opinion.
Okay.
Yeah.
All right. So in a previous conversation that you and I had, you
Yes.
mentioned that there are 4 categories of people
Yeah.
when dealing with deep learning. So can you just
Let's do
talk
3.
about?
Let's do 3.
Oh,
4
you
is a
cut
lot.
it down.
4 is a lot. Let's
You
cut
cut it down.
Well, I thought about it more.
There are now 3
yeah.
types of people.
Right. Well, I often say I'm very impulsive. So if you say,
Let's make it 5.
I'll be like, there's 10. No, I think there's 3.
I see your 5, and I
And
need
raise you
50.
right. No,
Go ahead.
I think there's 3. And this is a very local perspective. This is how the way that I see the world. So
Right.
the first kind of person is like our CTO, Dean. Okay, so Dean is basically a superhero, right? So Dean did a degree in mechanical engineering, electrical engineering, computer engineering, and then he has been a software developer working on like data intensive computation, machine learning, et cetera, for like the past 15 years.
So what do we call that type of person?
Superhero.
Superhero. Got it. First one is a superhero.
Right. And the thing about Dean is he can build a machine.
Yeah.
He can install arbitrary software on the machine, and then he can do arbitrary things on the machine, right? So like he is skilled in all 3 of those components. He mined a bunch of Bitcoin in his basement, a couple of years ago, and like he just bought some stuff, put it together, and was like, all right, let's do this, and made a couple $1,000s. And then when he got bored and it was too expensive, he turned it off.
So we can't all be Dean.
We can't all be Dean,
No.
right? But luckily, Dean, runs the technical aspect of our company, so like we're very lucky for that. So we can't all be Dean.
Yeah.
And then there's another person who doesn't have the facility with the hardware,
Okay.
and probably doesn't have the facility with some of the lower level software elements, but is perfectly capable in a Linux system, Bash terminal, knows Python, backwards and forwards, maybe even knows a little bit of C++. And if you give them some piece of software to install, they're like, you know what, I got this. It might take me a while, but like I'm going to do this, right? And that, that is also sort of a little bit of a rare breed, especially nowadays, where people are being forced out of sort of the more systems programming and more into sort of the more user-friendly programming, right?
So is this like
That's,
a data scientist, or what do you call?
So
this
I would say
person?
that's probably an experienced data. That's not a beginning data scientist.
Got
that's
it.
like a more experienced data
Experienced
scientist.
data
Because
scientist, okay.
a lot of data scientists, especially, they may not have a lot of experience in the Bash terminal, and there are varying levels of experience. Like there's Bash fakers. Like I'm a classic Bash faker, and a Bash faker is like you have some sort of a routine. Can I basically copy it? Yes. If it gets a little messed up, can I fix it a little bit? Yes. Do I understand what's going on? No.
Okay.
Right. So there's a lot of different
Yeah.
understanding there.
Okay.
And then there's the third person, which is more or less like me, which is either sort of Bash illiterate or a Bash faker,
Bash
right?
faker,
That can
yeah.
like follow, can sort of follow instructions as long as they're clear and fairly simple, but has a moderate amount of facility in Python and has enough of a quantitative background that if you give them a quantitative problem, they're going to be able to tackle it with Python or R or whatever.
Right.
But once you force them to dig into that software stack, they're like, prefer not to, right? So
Right.
for me, those are sort of the three types.
Okay, thank you. We have a couple of questions that came in. All right, from Amin, in your opinion, what are the current challenges or new areas in deep learning that a master's or PhD student should work on?
So what I think is interesting, so about a year and a half ago, we started, in terms of like our product development stuff, we began interviewing a bunch of data scientists that were in our network and worked at places, and we talked to them. And one of the most interesting conversations I had was with a woman who did a PhD, I think in meteorology or
Okay.
climate science. And then from there, she moved into being sort of a data science lead at a large company that got bought. And then later she left and started her own startup. And I said, like, what is your role on the team of these data scientists? And obviously you're doing a lot of deep learning. She's like, yeah, I write a lot of software. She said, but mostly what I do is I analyze the statistics. And so And she said that, one of the ways that people really work on their machine learning models and that sort of stuff is not just looking at the training error and things like that, but there are a lot of basic statistical problems that you can ask about it. And people have a lot of empirical evidence for what these statistics should look like. So doing the kind of analysis around the more statistical components, not just the computational stuff,
Right.
is something that is probably a pretty rich area, at least if you want to give yourself some job skills. Because she was basically like, I got this job because it was known that I had a lot of expertise in analyzing these kinds of statistics. So that's one thing. Other than that, I mean, I think that there are a lot of probably interesting mathematical questions that are going to come, like, subject disciplines, which is not exactly, computer science, but functional analysis, which is sort of, understanding classes of functions and operations on them and operators. I think that there's probably a lot of rich research in functional analytic methods applied to these kinds of function spaces, but it's hard.
Yeah.
Yeah. So.
Yeah, I assume the end goal for a PhD student is to be employable in the near future. Right?
Well, it used to be to get a tenure track job, and
Yeah.
then it became I want to be employable and
Yeah.
like make a lot of money. So don't know. It all
Depends on what the goals are, right?
Depends on what the goals are. Yeah.
All right, next question. Thank you for putting this together. Given what you discussed so far, what are your thoughts on startups that have to define the data science versus engineering versus business intelligence job descriptions?
That's tough. That is really hard, especially as you get higher up the decision stack and you get less technical. People don't really understand the differences. We struggle in it. We have struggled to explain that ourselves for a long time. So, like, I think the let's read the question one more time. Define.
Basically, companies.
Yeah. So, I mean, I for us, it's been basically, if you're creating some sort of a software or a service, there's always what you think it's good for, and then there's what it actually turns out to be good for. And so we've had a bit of that as well. And so it's this value proposition thing. But making the difference, especially, I think you can make a clear difference between data science and business intelligence, because business intelligence really is like, I've got like a terminal or like a UI and like it does a couple things and like it interacts with data, but really it's just
Like
producing
Tableau
charts.
or...
Exactly. Whereas data science is like, am I writing code in a script or a notebook? So that difference is clear. So, but between the data engineering and the data science is a harder proposition. But again, there, I think the world is largely reflected in the difference is what tools are the end users using, right? So like data engineering, a lot of people are using Spark, Databricks, and things like that. And then, for the data science part, maybe people are using different interfaces, or maybe they're doing it locally or in the cloud. So I don't know, that's kind of a messy answer, but like I feel you. Like it's hard to explain the difference to people.
I think maybe we should get rid of job titles altogether and just have job descriptions. Because it's so misleading. Sometimes you'll see, if you read the roles responsibilities without seeing the title, you probably think it's something
But then your problem is HR there, right? Because who writes those things? HR is sort of a mess. Like whether or not they really understand the things is a different story.
Yeah.
Yeah.
We can have a whole session just on that, actually.
Right.
All right. So let's talk about this article on Medium. So it's about using Docker, Machine, PyTorch, and Gigantum for portable and reproducible GPU workflows. You could not come up with a longer title, guys.
We could not. Yeah. Well, yes, and it's also like a long article. Yeah. We do a lot of things wrong, it turns out. But it was sort of, we wrote it. The reason why we wrote it was, so we have another guy on our team. His name is Dave.
Yes.
And right.
Dave
And
Clark.
so I wrote it with Dave,
Okay.
but it's under Dave's thing. But whatever.
It's fine, yeah.
So Dave did a PhD. So Dave's a very smart guy. Dave went to MIT. He went to University of Maryland. He did a PhD at Berkeley, and he did a PhD in psychology, but very sort of data science oriented. And he studied beliefs and opinions about climate change.
Yeah.
And then after that, he went to the Berkeley Institute for Data Science, which is sort of like an academic group around it. One of the first places. He was one of their first fellows. So Dave is another person kind of like Dean, very skilled, has done all kinds of things.
Superhero.
Dave is, I don't know, like I have Dean sort of on a pedestal. Dave, okay, Dave, fine. We'll go with Dave as a superhero.
Okay.
So, and we knew that our core users were like, we love this because this makes it so easy to stand up deep learning on like arbitrary instances. And so I was like, well, how easy is it? And Dave was like, well, you could do it. I was like, no, there's no way. So he said, yeah. So basically this article was just an exploration of like, he was like, if I show you how to install the drivers, you can just do the rest. And I was like, cool, let's do that.
Okay.
And so this article is sort of an exploration of that. And it's quasi-tutorial in that, like, if you have never set up a GPU EC2 instance, this will show you how to do it,
So
assuming
it's a step-by-step guide.
it's a step-by-step guide. And it walks you through the easy parts, and then what it does for the hard parts, it just says gigantum. Like just gigantum it.
Gigantum
And then you gigantum it.
a verb now?
It's a verb.
You just gigantum
To
it. then.
gigantum. And then after you gigantum it, then you have this transfer learning thing
Yeah.
that you can play with, which is a tutorial that Dave adapted from a guy, I forget his name, but it was a young guy. I think he works in India now. I think he had been in the States, but he made this very nice transfer learning thing. And so the other part of it was so we wanted to show how easy it was and how much gigantum solved those problems. The other thing that we wanted to show was how easy it is to move work back and forth. So PyTorch has this thing that will let you work on either CPU or GPU. And so the way that the tutorial is set up and the way that I did it was, first I sort of set up the thing on my laptop. I did it on my laptop and like ran like one epic, which took like 5 minutes or whatever.
Yeah.
And then later what I did was I pushed it up to this GPU instance and then just sort of banged it out. And the idea was to show that the work could just move around, didn't matter, move it here, move it there, move it everywhere, basically because gigantum acted as that sort of intermediary layer.
Right. Okay.
Yeah.
And actually, so on Gigantum, who would typically use this, and how would they go about getting this tool installed or downloaded?
So again, like, you know, if you can install Docker CE,
Yeah.
then you can use it. Done.
Okay.
Right? Well, I think there might be like a weird pseudo privilege around adding a user to the Docker group or something weird about that, but like, and that means you can do it on DigitalOcean because you can stand up an instance and install Docker. You can do it on AWS, etc. So there's that's the first part.
Yeah.
And we're about to change the whole installation process. So like we in about 2 weeks we're going to have like a completely new website, new version, all kinds of stuff that's going to make the download and install basically one button. It's going to automate a bunch of the Docker stuff, yada yada yada. So in terms of who's using it, like, you know, one of the people that has been using it is a guy named Will Kuhn who was at Harvard in medical school, and he's doing he studies sleep patterns. So he studies a lot of I think he studies EEG maybe.
Okay.
But so he's been using deep learning to do to study that, and he had a lot of problems around setting stuff up, etc. And a buddy of his said, "Hey, why don't you try Gigantum?" And then he started using it, and then he started using it all of the time, and he's become like one of our biggest advocates. And so, and the reason why he uses it is because he likes to be able to work on a variety of instances.
Right.
He likes to know basically what's running and when, and like Gigantum will sort of tell you that. And he likes the fact that he can build up a workflow, tear it down, move it, all of it totally reproducible, versioned, etc., with basically very little effort. And Will is probably not a superhero in that he probably couldn't make. He could do it, but just whether or not he would have the inclination and time.
Yeah.
But he's definitely like one of these people who's like, you know, pretty skilled in Linux and all this sort of stuff. And what he likes about it is that it just saves him a ridiculous amount of time.
So somebody uses it for the first time, then they fall in love with it, and then now he can't stop using it. That's what you're
Apparently.
saying. And then tell us more about, I think it works with Jupyter Labs and RStudio and all that, right?
Yeah. So and the way that it works basically is that it's supposed to let you work better without changing how you work. Right?
Yeah.
So the idea is that
That's
it's sort of
important.
it's like this UI, this interface that all this kind of stuff you want to manage, you can manage there. But when you go to do your actual work,
Yeah.
you pop to another tab and you work in the tab. There's right, and so you work in Jupyter, Jupyter Lab, RStudio, and there you just work basically natively. There are a couple weird issues because of the Docker read-write layer.
Yeah.
So like installing packages on the fly, something that you can do in an ordinary Python environment because Gigantum runs in Docker and all your work is in a Docker container. Little weird things there, that stuff will vanish, but there are easy ways to get around it. And again, really the goal is to just make all of these other things that you don't want to do or can't do, make them as easy as possible, and you just work.
All right.
Yeah.
Okay, last question for you is where can people go to find out more or
So
play with this kind
we
of
have
stuff?
we have a website, obviously, gigantum.com.
Okay.
We have a couple articles on Medium. I think there's a video or two online.
On YouTube, yep.
On
I've seen
YouTube,
those.
yeah. And then there's also, that's all going to be changing very, very soon. And then we have, if you go to gigantum.com/explore, there's a couple projects there that you can see and import. But again, that whole site is going to change really soon. We're moving towards.
So it's getting better?
No, the current site right now is bad. Like the
I actually
software
like
is
the
good.
current site.
It should be better. But soon,
Okay.
what's going to happen is you're going to go there. you're going to be able to like see something, and then you're going to be able to click on it, and you'll be able to like run it in the cloud. Not to like run it, because that's like not, I mean, you don't want to do that for various reasons, but to like look at it and explore it and be like, oh, run a cell or two, yeah, this is something cool, maybe I'll use this.
Yeah.
And then from there you can download it and use it, etc. So we're trying to make it this world where you can use the cloud to sort of see what you like.
Yeah.
And then when you want to use it, then maybe you download it, or you install Gigantum on EC2, you import it, you move it around. The idea is local is relative now.
Yeah.
Yeah, so.
All right. Well, we're getting some comments that this is all very interesting and people are loving this.
Ah, cool.
So, lastly, I just wanted to let you know, if you want to learn more, I tagged Tyler and Gigantum. You can follow the company page, and I put a link for gigantum.com where you can click and learn more information.
Or you can follow us on Twitter.
On Twitter as well.
Gigantum Science. I think it might be
Gigantum Science.
underscore. Yeah.
Yeah, I think it's Gigantum Science.
Yeah, maybe. I don't know.
Well, if you type in Gigantum, there's not many out
Right,
there.
they're not
so
many.
It's pretty unique.
Right.
All right, well, thank you, Tyler,
No,
for
thank
this.
you.
It's been really useful.
Okay.
Thank you guys for tuning in.
All right.
Have a good day, evening, morning. You know.
It gets hot in here, no?